for sharing it. Albert, are you ready to go?
Yes, I can share my screen if you're ready.
Terrific. Let me just say a few words. Very early in, I think, Albert's time arriving as a pediatric neurologist at Massachusetts General Hospital, through his mentorship with Florian Eichler, Florian being also a pediatric neurologist who is involved in, significantly involved in both clinical discovery and treatment for rare pediatric neurologic diseases. In my conversations with Florian Eichler, I said, we really would love to find somebody who can be a central person working closely on the clinical side with Yulia Grishchuk, who is a terrific pediatric neurologist who would love to start seeing our kids. And he said, I think I have the person for you. And that person was Albert Misko. And for several years now, we have been working closely with Albert. And for those of you who have had the pleasure of seeing him in clinic or seeing him at our conference, you know that he is that or seeing him when we brought him to Israel to see your kids in our whirlwind 3-day tour of the country. You know that he is that sensitive, smart, investigative, sees really careful, nuanced things. And he has poured an extraordinary amount of effort with his team of Maddie DeBono, Maddie Wave High, and Stephen Foley, who has just joined our team, into creating some extraordinary new tools for the ML4 community that have never existed before. Children with ML4 used to be measured along with a set of scales that were not designed for ML4. They were designed for cerebral palsy and for some other diseases. And so we got some measurements about how kids with ML4 were doing. We're not really based on how ML4 kids live their lives. And Dr. Misko has, in addition to seeing more ML4 kids than anyone else ever, has created some tools, some actual standardizing instruments to evaluate ML4 kids that are really defining new aspects of the disease in a sensitive way. So it has, in addition to the fact that, you know, he and Dr. Grishchuk and Dr. Wishart work as an incredible team, he's really taking investigation of this disease to new places and has taught me a lot as I work with him. So I'm delighted to be able to have him on this call and someone who we can count on going forward. Thank you, Albert.
Thank you, Rebecca. I'm going to try to share my screen now. Are you guys seeing my PowerPoint?
Not
No.
yet.
Okay, hold on.
There we go.
Okay, great. I have two screens and the camera's not pointing at the screen I have my PowerPoint on. So if it doesn't look like I'm looking directly at the screen, I promise I am. All right, so thank you so much. I want to start with a huge thank you to Rebecca and the tireless effort that you've put into organizing this amazing community and these conferences, and to Randy Gold for pushing the ML4 Foundation forward, and really all of the extraordinary effort. And then most of all, I want to say to all the families that have joined us today, everything that you're going to see in this presentation is because of the efforts that you've put in, both in being a motivated part of the research community and part of our team, but also all of the tireless fundraising that you've done. All of this work has been sponsored by you guys and is only possible because of the work that you've put into fundraising. So a huge thank you, and know that this data is your data. I'm going to give a talk on the clinical research aspect of ML4. As Rebecca had said earlier, I trained at the Massachusetts General Hospital in pediatric neurology, and then I joined the lab of Florian Eichler. And I mostly run the cellular and molecular biology lab looking at the fundamentals of neurometabolic disease. But when Rebecca came with this opportunity to be part of a clinical research effort, I found it was fascinating and that I couldn't say no. And now, having been involved in it, it's become a project that I absolutely love, because the families and the patients are just so amazing. And this has become one of the most meaningful things that I've ever worked on. And it's a huge part of what I do now. The heart and soul of our team, you can see all of these pictures aligned here. Maddie and Stephen are clinical research coordinators who are sponsored by the funding, the fundraising that you all have done. And they really are driving this project forward. They are the boots on the ground that are churning through the data, that are helping to organize and put things together. And a lot of what you're gonna see is the result of their efforts. And then we were so thrilled to have Brian Wishart join our team. He's been such an invaluable part of the clinical care of patients and helping us understand how best to support patients with ML4, both for their neurological symptoms and just sort of across the spectrum, all different sorts of therapeutic interventions that could be possible to help symptomatically treat patients. Some of you have seen Dr. Ann Fulton, who is our wonderful ophthalmologist at Children's Hospital Boston, who has been helping us understand the trajectory of retinal degeneration and visual impairment in children. This is a picture of Florian Eichler, my mentor, who is the director of the Center for Rare Neurological Diseases, of which we are all a part. And then, of course, Rebecca as well. This talk will be divided into two sections. The first part is an update on the natural history study. As has been stated, it can't be overstated how important understanding the natural history of a disease is. One, to help care for the patients and actually understand what's going on, but also to come up with meaningful endpoints and an understanding of what a successful treatment would look like going into a clinical trial. The Federal Drug Administration really wants to know, if you're going to put kids at risk and give them an experimental treatment, how are you going to know it works? And the only way to know that is to understand the disease well enough and be able to show them that you understand the disease well enough that you can come up with these meaningful endpoints. And by endpoints, I just mean this could be, perhaps you could, it's an improvement in motor function. And you're going to have to show, well, what kind of improvement is that? How much improvement is that? And that's what we're working on. The second part of the talk is going to be how this natural history study has helped our understanding of ML4 in the way that, like, what can we do for patients as a result of it? And we're going to go through a lot of topics. I do want to put I have to preface this that, this is not medical advice legally. I cannot give medical advice like this over a presentation. And these are also not binding guidelines. This is simply our best understanding to date and suggestions. And we're constantly working to understand more and more about what the best supportive therapy for children with ML4 are. So let's dive into it, and we'll get right into the natural history study to start with. You'll also see pictures that I've taken off the ML4 website, so you may see your kids pop up here. But the first part, so the goals of the natural history study, again, are better understand how ML4 affects patients, aiming to improve patient care, and also to promote clinical trial readiness and design. This can't be done without medical records. They're so important because Yulia has made such tremendous progress in bringing this treatment to fruition for these children that it's going to be ready way before we would ever be able to prospectively, or that means going forward in the future, follow kids and understand the disease. What we have to do now is go backwards and try to understand everything that's ever happened in the past, sort of like detectives, to be able to trace how the disease evolves over time so that we can go to the FDA in a timely manner to come up with endpoints. So what does it look like and how do we approach this? This is going to be a busy slide, this next one, but there are some things that I want to point out about it and break it down for you. So this is where we started right here, and it was just enrolling patients. And currently we have 39 patients enrolled from all over the world. I've been lucky enough to see 26 of them in person, both at the ML4 conference, in patient visits to my clinic, and traveling to Israel, and there should be many more to come. We also have 8 additional patients that we are aware of, but we have not yet enrolled in our study, because as I will tell you in a few minutes too, the next phase of our study is ready to sort of hit the ground running, but we're waiting for IRB approval on the second phase still. So the approach was to first enroll all of these patients, to see them, and then to apply known scales of function. And what that means is, so if you came to me in my clinic, I would examine you and head to toe, full neurological examination and get an idea of both neurological function, which means what can you do? Can you sit? Can you stand? Can you use your fingers? How well can you use your fingers? And then also symptom severity. And what does symptom severity mean? That means how bad are some of these symptoms? How bad is the muscle tightness? How bad is the weakness? How bad is discoordination or tremor? But when you come see a clinician and they write their note, a lot of this is qualitative and there is some quantitative aspects to that. And that means, can you really measure it? Can you put a number to it? And numbers are important when you're trying to come up with endpoints for clinical trials, because you have to be able to do statistical analysis to show real changes that occur thanks to a treatment. So when I saw patients in my clinic and in these visits, I was taking scales of function and symptoms that already existed, but I knew weren't going to be ideal, because the more and more patients I saw, I realized that these scales really didn't capture exactly what was going on in ML4, but we needed a starting point, and this is where we started with. So a cross-sectional analysis was the very first part of our study. And what does cross-section mean? Cross-section means you're not going back in time and looking at what happened, and you're not going forward in time. You're simply saying, right now, at this point in time, what's going on? You examine kids from early all the way through late stages of life and try to understand across the age spectrum how symptoms evolve. And that's what we did. So that part is actually complete. It's being written up right now. It's going to be published in a scientific journal, along with another paper that Yulia is authoring on biomarkers, which was also a result of all the participation of families at the ML4 conference in Atlanta 2 years ago. From the cross-sectional study, and part of the cross-sectional study was to collect medical records, we're now taking the medical records that we have and we're doing a retrospective analysis, and that's this square down here. And we're collecting every piece of data we possibly can on ML4, everything from demographic data and the genetic diagnoses to understanding when children have met their developmental milestones, when have they lost those developmental milestones, what kind of data is available out there? How about brain images, EEGs that show brain activity, EMGs that show muscle activity, ophthalmological data that show visual function. And then finally, we're going to take every single examination that's been documented in those medical records and use those as information or data to which we can apply our own new scales. And I'm going to talk a little bit about these new scales very briefly. I found it very hard to illustrate them on a PowerPoint. And I'm hoping when I meet you all in person the next time, we'll be going over all of these scales and you'll have a better idea of what they are when you see them in person. But one of the scales is an ML4 specific functional scale, which we've named ML4FS. And this can be applied to medical records and track neurological function and symptom severity over time. Applying these to records will give us the chance to, one, actually track progress in ML4, and also it'll allow us to show that these scales are valid and that they can be used in an upcoming clinical trial. So this is what's ongoing right now. This is a tremendous amount of work, but now that we have both Stephen and Maddie on board, we're making some real forward progress, and I'm extremely proud of the work that they've been doing and the progress that we've been making. This retrospective analysis, again, will be the backbone of what we need to go forward to the FDA in sort of setting up and getting approval for our clinical trial. So again, I'll say this many, many times throughout the talk, any and all medical records that you guys have, we can try to help you get them. If you can get them and send them to us, anything we can do to get more data, it makes this retrospective analysis stronger and stronger, and that means more meaningful. At the same time, we are now at a stage where we can launch our prospective analysis. Prospective means going forward in time. So we have these 39 patients. Can we follow them year from year and figure out how things change over time? Now, again, as I said earlier, the treatment and the clinical trial are going to be coming up within, several years, hopefully even sooner. So we're not going to have a chance to complete a prospective trial before the clinical trial. However, it will be an ongoing effort, and it's important to start it as soon as possible. So After having completed this, we put in a new request to the IRB. And what an IRB is, it's a committee that sits in Massachusetts General Hospital, and they're involved in protecting patients. And so whatever we want to do in terms of a prospective study, they have to approve it and say, yeah, that's okay. And we're awaiting the approval now. It probably would have already been approved, but with the COVID-19 pandemic, things got a little bit delayed, as you can imagine. They did finally get back to us with some reviewer comments, and we're submitting our second draft. So hopefully that will be approved soon. And we've been waiting for that approval before we go forward with any more enrollment, because we'd like to switch everyone over to this new protocol, which will cover both the retrospective and the prospective study. So what does a prospective study look like? Well, right now, the way that we've envisioned it is that we would be doing annual assessments, or in younger children, maybe even sooner, both in person and actually online too with patient surveys. So at the minimal, I would see patients once a year in my clinic or at the conference or perhaps at the homes in different countries, and we would be applying certain scales. One of them is the ML4 functional scale that I told you about, but again, I'm not able to illustrate it very well. I'll tell you some about some of the domains that it tests. And then some other scales, this gross motor functional scale that we found that's been developed for kids with cerebral palsy. It's very detailed. I don't think it'll be good as the ML4FS, but it's important to have more than one scale going forward so our study is more robust. We've also developed caregiver functional surveys, which will be really important. They're very detailed and they ask lots of questions about function in ML4 children. We can use those and compare them to our own investigator applied scales and show their validity, and then take these and administer them online to make caregivers and parents active participants, active investigators in our prospective study. And that's what we're working towards right now. There is a Vineland-2 survey for caregivers that you may have already taken. We've decided to use this one instead of more updated ones because retrospectively, the Vineland-2 has been used in other studies and also on a lot of children with ML4 that were seen at the NIH. And the only way to make the data consistent and comparable so we can use the past scores to future scores is to use the same scale. And then finally, we've come up with a quality of life survey, because as much as we can show change in function and symptoms, we have to know if it's meaningful. Say, I could judge your strength on a scale of 0 to 10, 10 being your strongest and 0 being no strength at all. And say that scale was perfectly accurate and reproducible every time. If I told you I can improve your strength from a 9 to a 10, what the FDA is going to want to know is, does that mean anything? And it may or may not. And that's what the quality of life survey is trying to find out. We're also doing, part of it will be with Dr. Ann Fulton with the continued ophthalmological assessments and trying to understand the progression of vision loss, along with labs and imaging modalities as clinically indicated. So right now, our prospective study is completely funded again by the fundraising efforts of families. We are actively applying and trying to convince the FDA and the NIH to fund this prospective study so that we can use those funds to do things like brain imaging and looking at EEG data or brain activity. But as of right now, we don't have the funds to do that. So the only time we can ever do imaging or an EEG or anything else like that is if it's clinically indicated, meaning if you were going to come to me as your pediatric neurologist, would I do this test regardless of the research? And that's the only stuff that we can do right now. But hopefully in the future, as we gain more funding, we'll be able to expand on the amount of things that we're able to do on a research basis. Okay, so I want to show you now some of the results. And it's going to look technical, and that's okay. What I really want to show you and impress upon you is everything that we've been able to do because of your participation. So let's start out and just illustrate, well, what does our cohort look like? What does it look like in terms of the 39 people that have enrolled? So here's a distribution of ages. On the y-axis on the left, you have number of patients, and then here are the ages of the patients. So right now in our cohort, we have kids everywhere from about 4 years of age all the way up to about 42, 43 years of age. And you can see they're spread out across all different age ranges. And that's been phenomenal because it's been given us a chance to see what does mucolipidosis type 4 look like in patients early on in life, in adolescence, in the 20s and 30s, and then finally in 40s and very old. And that's been extremely important. We have a nice spread of gender, 67% female, 38% male. And then ethnicity, people are coming from all over the world. Ashkenazi Jewish descent, Caucasian, Asian, Latin American, African American. And we have new patients now coming from Eastern Europe, from the UK, from all over the place. So really ML4 is a pan-ethnic disease that affects people from all walks of life. And that's really important because we want to get the perspective of all patients, see what the challenges of all patients are, and then sort of move forward to making these meaningful endpoints for clinical trials so that they're meaningful for everybody. Okay, let's get into some more of the technical stuff in terms of function and what it looks like. All right, here are a bunch of busy graphs, but let me just break it down to you so that you leave with the most important information. This was the data from the cross-sectional study. So again, this means that we just saw every patient one time. When you're looking at these graphs, every dot is one patient. At the bottom is the age of the patient from 0 or from very early all the way up to the 40s. And for each axis here on the Y, it's going to be a score of function. And let's go over each one individually. This first graph is looking at gross motor function. This is a measure of sort of gross motor function is like the broad strokes of your motor function. It's sitting, it's standing, it's supporting your trunk, supporting your head, those sorts of things. And we know there are significant challenges in ML4 with gross motor function. The higher the score, the more function those children had. The lower the score, the worse the function is. And there is a trend over time from improved function or better function to worsening function with age. And that's important because previously, ML4 was described as a static neurological condition, meaning it was thought that only about 15% of kids actually got worse. And it was thought then that means that about 85% of kids were just staying stably impaired. But we knew from talking with patients and parents that that was not the case, that over time symptoms were getting worse, and we need to be able to track that. And this supports that. Now, look, there's a spread, right? There's some noise here. These things are all spread out. It's not a perfect line, and that's okay. That's because each individual patient is different. And part of what I'm going to talk about going forward is how we can uniquely tailor endpoints to each patient as well as a population as a whole. Now, you'll notice that there are some dark dots and there are some light dots. The light dots are patients that were more mildly affected and that we considered to be atypical. Now, we just arbitrarily sort of made a definition of that. If a child or a patient has ever been able to walk on their own without support, that was atypical, because the vast majority of patients that we talk to have never been able to do that. It helps our statistical analysis to be able to separate those children out. And that's what you see here, the light versus the dark dots. The next graph is upper motor extremity function. It's just a bit more detailed than looking at just the arms and not the arms, the legs, and the trunk. And you can see over time too, there is a trend towards worsening function over the lifetime. The same is true for fine motor function, which is ability to use fingers, reach for objects, manipulate those objects with two hands, use a sippy cup, use a utensil. And then finally, this is just one more score. This is called the GMFCS. So the lower the level of the GCMFS, the better the function. And the higher score, the worse the function. And you can see the same trend over the lifetime of the patients. So the takeaway from this slide is that I think we're going to use this data to debunk the idea that ML4 is not a progressive disorder. It shows us that everyone is sort of an individual and that they're not going to all probably follow the same line. It also shows us, which is hard to see from here, but I'm going to tell you that the scales that we were using here, these are not ML4 specific scales. They're not good enough to capture the real progression. That's part of why there's so much spread. And then finally, so we debunked it. We know they're not good enough. We're using this data to help us make the new scales. So this was the basis for the new scales that we've also developed. Okay, so that was motor function in general. But what about things like articulation, which is the ability to like make words, or deglutition, which is swallowing? Well, it was really interesting actually. Over time, there's not much of a trend. Higher scores are better function for articulation and lower scores are worse. And for the most part, children with ML4 really are at the lower end of these scales because we know that ML4 really impacts the ability to articulate words or use words and language. And this stayed stably bad across the lifetime. The same with deglutition, actually, but you'll notice that the scores are higher. So one of the surprising things are, and you guys already know this as family members, the challenges we see in almost all kids with ML4 are with chewing. So when you and I chew, we use a rotary jaw motion, right? We chomp, we sort of like move our jaw in a circular motion when we chew. Children with ML4 have a more primitive type of chewing movement. They chomp like that, just kind of up and down. The other is that most of these kids have very poor control of their tongue. So it's very hard to move a bolus of food to your teeth to chew it, and then to move it to the back of your throat to swallow it. And that ends up in prolonging the amount of time that it takes for kids to eat. But what was really interesting was that swallowing seemed not to be so impaired. In fact, talking to most patients and families, swallow studies have been done over the lifetime of most of these patients. And for the most part, there's not a lot of evidence of aspiration, or that is to say, having food or liquid enter the lungs instead of the stomach. And that's really great. Unfortunately, that's not true for later on in life. And you can see here in the 40s, and eventually that does become an issue. We're not exactly sure when it becomes an issue. We're trying to figure that out from the retrospective study to get a better idea. But we know when time goes on, maybe into that fourth decade of life, aspiration may become an issue. However, for the sake of the clinical trial, what this tells us, the takeaway is that we're probably not going to be looking to prevent worsening of articulation because it seems to be stable. We're hoping in the clinical trial that we would see improvement in articulation. And with deglutition, you can see, because these scores are already so high, we're going to have to come up with some better way of measuring it. And we'll talk about that a little bit later. We haven't come up with the perfect tests yet, and those are in development as well. Okay. Finally, the last sort of busy data slide here, but again, this is really important. One of the symptoms that we noticed was most pronounced in kids with ML4 was muscle tone. And we're going to talk about muscle tone in a little bit too. But muscle tone basically is the resistance to passive movement at a joint. And you guys know this as muscle stiffness. And muscle stiffness is something that all patients experience and that all parents have reported. So these scales are looking at muscle stiffness, and again, age going from youngest to oldest patient. Each dot is a patient. And this is a scale where 0 is normal muscle tone and 4 is really tight, stiff muscle tone. And you can see the projection across the lifetime. Younger kids have less high muscle tone or better, more normal muscle tone. And then as these patients get older and older and older, that muscle tone gets worse and worse and worse. So this is something that in the clinical trials we hope to target and prevent. We want to actively see that this curve gets flattened out or improves. Each one of these graphs just represents tone at a different joint. So here is at the elbows, at the wrists, at the knee, and at the ankle. And so increased tone affects all 4 limbs from what I saw in our cross-sectional study, and pretty much everywhere in the body, all these joints. The hips were an exception, but those aren't plotted on here. Okay, so at this point, we've been able to show that neurological function gets worse over the lifetime. We've been able to show that symptoms are also getting worse over the lifetime. And again, this is going to be so important moving forward because this is the first quantitative data, meaning that for the first time, we've been able to put numbers to this to be able to show the FDA what this looks like. There's one other interesting thing we did. We wanted to know at what point are kids losing functions? And very early in life, most patients are still developing and they're gaining function because the normal sort of uh, development, the developmental processes are pushing function forward or improving. But at the same time, there's the ML4 disease process trying to push it down and prevent that development from progressing. But at some point, we stop developing, right? Developmental milestones, leaps and bounds early on in life. But then as you get older and older, it kind of plateaus out and levels out. And we wanted to know, like in adolescence or later on, when sort of development slows down, does the disease process of ML4 start impacting patients in a way that it's taking away things that they can do? What we did is, and those of you who were part of this might remember the Oregon Developmental Checklist. It was the extraordinary long and painful survey of all different types of functions, asking whether or not your children were able to do them, had been able to do them in the past and lost the function, or was never able to do them. And so thank you so much for answering all of those questions with us, because it actually led to some important insights. So let's look at these graphs. Again, there's age from youngest to oldest, from left to right for all of these. And each dot, again, is one patient. And on this axis here, the y-axis, what we're representing is, this is the age at which each of these patients were interviewed. And we asked the parents, how many of these different sort of abilities has your child lost? And that's the number on this axis. How many abilities were lost? This very first one, actually, let's do these in aggregate. This is gross motor skills. This is fine motor skills. This is self-help, like the ability to brush teeth and help with dressing. And this is compensatory skills. And those are sort of life skills like self-soothing and the like. And the trend here, what you can see is that early in life, no one's really reporting losing skills, right? There's 0 lost skills in all of these graphs very early on. But once you get to a certain age, 15, 14, early adolescence, this is about the time of a growth spurt, about the time for puberty, and about the time when vision is almost completely lost or at its nadir, its worst. Parents started reporting lost functions. So we know that in early adolescence now, that this is the time that we can start expecting to see where development has slowed down. And now the disease process, the ML4, is actually pushing function down, impairing function, and making it worse. So this is a really critical window right here. For language, it was the only one that was not true. So language, kids tended to lose language early on. And so for all ages, it was sort of affected, and development wasn't of language wasn't as dynamic as we needed it to be able to measure it. So what I'm trying to say is, I don't think that measurements of language regression later on will be as helpful, but for the gross motor functions, looking at preservation of function and stopping progression of disease will be really helpful in our upcoming clinical trials. So let's get a summary, because that was a lot of data here. So what are some of the take homes here? And let me translate some of this. Basically, in terms of motor function, gross and fine motor function, it gets worse over time. And again, this is the first quantitative demonstration of that in ML4. Muscle tone, high muscle tone, stiffness gets worse over time. Again, this is the first quantitative demonstration of that, and that's very important. Swallowing and articulation of words didn't seem to change much. Articulation seemed to be pretty highly impacted even early on and stayed the same. Deglutition, was also impacted in terms of the ability to chew and use the tongue, but it also seemed to be stable over time. And then finally, we started to define the age at which patients start to lose function, which is really important. And this was all thanks again to your guys' participation. Products that have come out from this now. Let's briefly discuss the ML4 scales. We now have an ML4 specific functional and symptom severity scale. This again is looking at gross motor function, fine motor function, language, both expressive and receptive, swallowing and self-help. But unlike the scales that you saw before, we listened to everything that every patient and every family caregiver told us over time about the challenges that children were facing. And we've incorporated all of those functions and challenges into this scale. My hope for this scale is that it's going to be dynamic meaning that it's going to be able to trace both improvements in function early in life, but then it'll also track and be able to show loss of function later in life. And now we know when that happens. So this will be really important because, as Yulia was saying, we're really hoping that with the treatment, with the gene therapy, we're not going to just be trying to stop worsening function. We're going to be trying to improve function to help or release that developmental trajectory so that we see improvements. And this scale will allow us to do that. I really wish those videos would have worked. Let me just tell you, I've seen those mice. I've seen the videos and I've seen the mice in person. And the untreated mice, it doesn't take an expert. Their motor function is severely impaired and they just look sick from a mile away. And the mice that Yulia treated, even at 2 months, when they already had symptoms, I couldn't tell them apart from wild type or just normal healthy mice. It was that impressive. And that's really driven in sort of our thought process about these scales. I really think we need to be able to capture improvements in function, not just show that symptoms aren't getting worse. And that's what these scales will do. Again, as I mentioned, there's also a symptom and function survey that's specifically tailored and designed for caregivers to answer. And I'm hoping that that can be validated so that we can do that online as well. In a way, we're hoping to train every single parent and caregiver as an investigator that can help us collect data at home, because in rare disorders, kids come from all over the world. And it's asking a lot to bring people to one place like Boston to be seen on a yearly or maybe even every 6 months. But if we can show that collecting data at home through parents, training parents as researchers is a valid way of tracking things, that can be an extraordinary tool for us. And finally, the quality of life or symptom impact survey, which is really important again, because when we go to the FDA, we can use these two scales to be able to show them that we can track changes, but we need to be able to show them what changes are meaningful and what changes would mean success to parents and patients. And this may be for the community as a whole, but we're also hoping that it's also individualized, because what we're learning from rare disorders all over across the board is that there's a phenotypic spread. And what I mean by that is everyone is an individual and everyone has their own individual challenges. You saw in those graphs how they're not a perfect line. They're spread all over the place. And so everyone has their own individual trajectory in life. And we're trying to help capture that and use those individual, those unique aspects of everyone's unique trajectory to form their own endpoints for a clinical trial so that they're meaningful, not just across the board, but to individual patients and family members as well. So what do we need to do next and where are we going? So one huge thing is, of course, enrolling more patients and collecting more records. So anything you can do is extremely helpful. If your child was seen in the past at the National Eye Institute and the National Institute of Health, we're having a lot of trouble getting records from the National Eye Institute. There's so much valuable data there. We've been reaching out and asking them, but if you can also try to reach the National Eye Institute and request those records, it's going to be a lot harder for them to say no to the parents than it is to us, and it would be invaluable data. Anything you can get to us is going to go right into that retrospective analysis that's ongoing, which Maddie and Stephen are working on tirelessly. And again, this is going to be the heart of the data going forward to the FDA, trying to get that clinical trial going. And then finally, you'll hear much more about this in the future, is the prospective natural history study, which is going to basically be a continuation of the retrospective and the cross-sectional studies. Annual patient visits, the caregiver surveys, and also I want to talk about these patient and family videos. I'll talk about this a little bit later on too, and I'm going to send out more information. This isn't approved yet. I can't ask you to do this as of yet because we need IRB approval of the prospective study, as I had mentioned earlier. But the ML4 Foundation is also very interested in this. So Rebecca and through the ML4 Foundation, there are sort of things that we have collectively come up with, instructions to guide making patient videos. Okay, so the next part, let's take a slight breather here. Let's talk about an update on clinical care of ML4 patients. So we've done all of this work for the natural history. How is this informed how we can take care of patients with ML4? Again, this is going to be sharing insights, but it is not medical. These are not, I can't give you medical advice. This is not official medical advice. What it is and what I'm hoping is that this is a guide so that you can take this information to your care providers, be it your pediatrician or your PCP, your gastroenterologist, your neurologist, and say, hey, this is what we know now, and these are suggestions or things that may work, and they'll know these things. There is nothing, when we go through all of these things, these different treatment options, there's nothing that's specific to ML4. And what I mean by that is if I talk about treatments for high muscle tone, those would be the same treatments that we would use for any other patients with different disorders that have high muscle tone. But knowing details about ML4 and the types of high muscle tone are really important because those can guide different treatments, which I'm about to talk about. Also, these slides will be available to you. I did email Rebecca saying consent to share all these slides, but also we're working on a packet, and it's almost done, of sort of not care guidelines again, but suggestions and insights into the different symptoms that accompany ML4 and possible treatments, so that you can take this packet to your care providers and help inform them on what might be helpful or what we know about the disease. So let's talk about high muscle tone first, because this is something on everybody's mind. So what is high muscle tone and how do we treat it? I want to throw out there two terms right away: spasticity and dystonia. So before we started our study, if you went into the literature and read about high muscle tone in ML4, everything would identify that muscle tone as spasticity. And we had never read anything about dystonia. What is spasticity? Let's start there, because this is what was pervasive in the literature. This is, don't worry if the lettering is too small. I don't want you to have to see this. I'm going to explain everything. All I want you to see is a muscle and a spinal cord. And what I want you to know is that your spinal cord and your muscles are in constant communication. And your spinal cord and muscles, sort of the circuits or the programs that are run between them, are very primitive. So they don't involve your brain. You do them without thinking. And one of those circuits or programs are your reflexes. Now, you've all been to the doctor and they hit you on the bicep or the knee, and it makes you jerk your arm or your leg. That's a reflex. And all of that only involves your muscle and your spine. You don't need your brain to do it. In fact, what your brain does is it suppresses those reflexes and makes them go away so that you can move and hold your posture in different places. When you're not thinking, that reflex is really important, because what it does is it maintains your position in space. So if I take your arm and you're not thinking about it and I'm moving it back and forth, there's a bit of resistance. And that resistance comes from this reflex, the spine talking to the muscle. Now, I told you that the brain actually stops this reflex from happening, right? So what happens when your brain is injured? Well, if your brain's not working right, like in ML4, it stops talking to the spine and stopping this reflex. So this reflex actually becomes stronger and stronger with time. And that's what spasticity is. Spasticity is when the brain, because of ongoing dysfunction, is not able to inhibit this reflex. And this reflex becomes strong, 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 so that you become really stiff and it's holding you in place. And you know what this looks like, right? Because you see this in your kids all the time. But there are characteristics of this. When it's the reflex, the spinal reflex, when I go to move your child's arm, what I'm looking at is that resistance that I feel, does it change when I go faster or slower? Because this reflex, if I move your arm faster, it becomes stronger and you get really tight. And if you go really slow, the tightness is still there, but it's not quite as bad. And I know that's spasticity. We call that velocity dependence. But after I started seeing kids, we started seeing that there was absolutely spasticity that got worse over the lifetime, but that wasn't the only kind of muscle tightness. There was this other kind of muscle tightness called dystonia. And dystonia is not attributable to this reflex involving the spine and the muscle, but rather involves parts of the brain, these deep parts of the brain in here. And don't worry about the labels. All I want you to know is it's called the basal ganglia, and it's deep in the brain. This program, or this circuit, is really important in you maintaining your posture, and as such is also important in muscle tone. The difference in dystonia is that it's not velocity dependent, and it tends to come and go. And it can look like this, but you'll probably all notice this too. It can also look like this in the lower extremities. And what you see here is a foot that's turned in and then the toes curled. And this is a really common finding across lots of children. And this is a form of dystonic posturing or dystonia. So again, this is high muscle tone, but it's a different kind of muscle stiffness. What I can tell you anecdotally, which just means from my experience, is that spasticity seems to be getting worse from younger to older patients, whereas dystonia seems to be there constantly. But then as kids get older, the spasticity becomes so bad, you don't see the dystonia as much. But this is important because there are different types of treatments. Some of them are overlapping.